Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize the big stories in the universe. That's right. We're going to talk about the state of the universe. And then in the second half of today's program, we're going to bring on our favorite astronomer, Ken Croswell of Berkeley. He's the author of a number of great books in astronomy, including Alchemy of the Heavens. And so we're going to talk about the state of the universe. You know, on Exploration, we've talked about global warming. We've talked about nuclear proliferation. We talked about the potentials of biotechnology. And now let's talk about the state of the universe. Did you know that recently there was a meteor that exploded in outer space with the force of 10 times the Hiroshima bomb? That's right. An object which blew up over the Bering Sea blew up with the force of 10 Hiroshima bombs. And it caught us totally off guard. We were not prepared for that. And in fact, if that object had hit, it could easily have taken out a city on the planet Earth. And an object like that occurs perhaps a few times every 100 years. And so it gives us pause, realizing that, yes, we have problems with global warming, problems of nuclear proliferation, problems of germs that are weaponized and out of control. And we also have the problem of, yes, asteroids and meteors from outer space. And so we're going to take a sum up of what's happening in our own backyard, in our solar system, and in our galaxy. First of all, let's get some definitions off the ground, because we're going to be using these terms a lot. Comets, meteors, asteroids, meteorites, what are they? Well, first of all, when you have a rock in space before it hits the Earth, it's called a meteoroid. So a meteoroid is basically a rock in outer space, but once it hits the atmosphere, friction burns it up, and it creates a streak of light that dashes across the horizon, and that object is perhaps the size of a grain of sand all the way out to perhaps the size of an apartment building, and it can cause a lot of damage if it hits the planet Earth. Once it impacts on the planet Earth, it's called a meteorite. And so it's a meteoroid when it's a rock in space. It's a meteor when it causes that streak of light whizzing across the night sky. And then it's a meteorite when it actually impacts on the ground. And then an asteroid is a rock in space, usually found between Mars and Jupiter. There is perhaps a failed planet that never quite materialized between Mars and Jupiter. And that's the source of most asteroids. But many asteroids, of course, can go outside that asteroid belt, and then they can become, in fact, meteors. And then we have comets. Comets are totally different than meteors. Comets come from way outside the solar system, in fact, in the Kuiper belt of comets and the Oort cloud of comets. And they're basically dirty icebergs. That is, gigantic balls of ice and rock that are leftovers from the original formation of the solar system. And so once again, most meteors, not all, but most meteors come from a failed planet that never quite materialized between Mars and Jupiter. And when they hit the Earth, they create meteors. But comets can linger in the night sky for weeks at a time, frightening people, giving rumors about the death of kings and the fall of empires. And so history, our own history, is linked with comets. For example, Halley's Comet. Halley's Comet sailed over England in 1066, paralyzed the troops of King Harold, paving the way for the victory of William the Conqueror, who created the modern dynasty of England. So in some sense, England, you might say, is a child of the comet. So let's now talk about what's happening in the news. As we mentioned, a meteor blew up over the Bering Sea. with a force of 10 Hiroshima bombs, caught everyone by surprise. An object like that erupts perhaps once or twice every 100 years. And we have to realize that, well, these things do happen. For example, back in 1908 in Tunguska in Siberia, there was an object about the size of an apartment building which plowed into Russia, flattening a huge area of forest in Siberia, and it created atmospheric disturbances. It was so great, the impact. And expeditions that have gone to Siberia say that it's like a gigantic hand. Hand came down and flattened the forest and all the trees for miles around. If that object had hit a city, it would easily have been a city buster capable of taking out a modern city. Fortunately, the impact took place in Siberia, and then in 2013, again, Russia was the target. This object hit Chelyabinsk in Russia, shattered windows, caused injuries, in fact, and it was also about the size of an apartment building. And so we have now a third object that sailed over Russia. This time it actually blew up over the Bering Sea, creating quite astronomers off guard. How dangerous are they, and what's going to be happening in the future? First of all, these are city busters. However, a nation buster is an object which is much bigger, the size of, let's say, several football fields. And a nation buster could actually come whizzing by the Earth around 2029. And soon afterwards, it'll make a second pass. This is called Apophis. Apophis is an asteroid bigger than the Rose Bowl. And if it were to hit the Earth, it would probably take out a small country like England, for example. It's a nation buster. And then we have planet busters. Planet busters can hit the Earth not on a scale of centuries or millennia, but on a scale of tens of millions of years. We think that 65 million years ago, an object about 6 miles across plowed into the Yucatan of Mexico, creating a tremendous firestorm of debris, lifting tremendous amounts of dirt in the atmosphere, which then wiped out sunlight, and it eventually caused the extinction of the dinosaurs. So in some sense, we humans are children of the asteroid. If that asteroid had missed the Earth 65 million years ago, we wouldn't be here. There'd be dinosaurs here. Dinosaurs would still rule the Earth. And then the next question is, well, yes, we know that these things can take out an entire planet. They can take out a nation. They can take out a city. But what are we going to do about it? Well, most of us have the image of Bruce Willis in the movie Armageddon. He jumps into the space shuttle, and he basically detonates a hydrogen bomb in outer space. Well, that's not going to happen. First of all, the space shuttle has been canceled. Not only that, but the replacement for the space shuttle, the Constellation, was also canceled. And right now we hitchhike. We hitchhike on the Russian space program, but even their Soyuz rocket cannot reach deep space. You see, our rockets, even though they take off with a gigantic fury of exhaust and tremendous amount of debris, they cannot reach deep space. They only orbit around the planet Earth. So in other words, we are sitting ducks. We're sitting ducks. We have no defense whatsoever when an object comes barreling in outer space and hits the planet Earth. Well, first of all, let's get real about this. These are very rare events. There are about 10,000 or so near-Earth orbits, near-Earth objects that orbit near the orbit of the planet Earth that could conceivably hit the Earth. However, we track them. We have Newton's laws of gravity, Newton's laws of motion, and that allows us to run the videotape forward and then calculate when these objects may hit the Earth. And so, yes, Apophis is an asteroid that could go whizzing by the Earth, but it's not expected to hit the Earth, creating an impact. And so for the foreseeable future, that is going into the next 100, 200 years, we don't think of any large object that's going to hit the Earth. However, that's because our radars are only good and telescopes are only good for large objects, let's say bigger than a football field. When you start to talk about objects smaller than a football field, there could be millions of them that we don't track at all. And they're the ones that light up the night sky. They're the ones that cause a mini panic when we realize, oh my God, yes, these things are out there. They can hit the Earth, and we are defenseless. At the present time, we have no mechanism whatsoever to intercept, deflect, or blow up any of these objects that could come barreling down to the planet Earth. However, there are plans. However, they're financed by private individuals, not by the government. There are plans to set up, first of all, a satellite that would map small objects. Not objects bigger than a football field, but objects smaller than a football field. There are plans to launch, using private funds, a satellite that would track smaller objects so that we will have a handle on it. But once we do find something that is headed to the planet Earth, what do? Well, we can cross our fingers and hope and pray, because at the present time we have no capability. In fact, in the foreseeable future, we have no capabilities of intercepting these objects in deep space. However, unmanned objects, our robot craft, can actually go whizzing by some of these objects, and that's what we're doing right now. The Japanese and NASA, yes, they have intercepted not one, but 2 asteroids in outer space. Now, these 2 spacecrafts, the Japanese Hayabusa and the United States OSIRIS-REx, have successfully intercepted asteroids in outer space, and they've come up with some surprises. First, they find that these asteroids are not stable like we once thought. We once thought they were totally inert, but they actually eject materials. For reasons we don't quite understand, yes, materials, rocks basically, are being flung out from these asteroids, and we don't quite know why. But another mystery that we hope to solve is the question of, where did the water in our solar system come from? The Earth is different from the other planets in the solar system because we have these gorgeous oceans. About 3/4 of the surface of the Earth are covered with water. Water sustains us, is where life first got started. But then the question is, well, where did the water come from? We once thought that the water came from comets, because after all, comets are made out of dirty snowballs. That is dirt and ice. And so we thought that once upon a time, comets were the source of the water that we drink every day. But then we analyzed the atomic structure and composition of the water, and we found out the deuterium ratio was not the ratio we find on the planet Earth. So at the present time, even though this is not verified, we think that asteroids, not comets from deep space, but asteroids within our solar system, is where the water of the Earth came from. However, we don't know for sure, but we hope that the data from the Hayabusa and the data from the OSIRIS-REx would help to solve the mystery of where the water of our solar system originally came from. And also we should point out that Google billionaires are jumping in the game. They see asteroids not just as an object of study, but asteroids as a source of a new gold rush. That's right, mining the asteroid belt is what these Google billionaires would like to do. And they've even set up a company to explore the possibility of retrieving an asteroid and bringing it back down to the planet Earth. Now, you might say to yourself, why? They're just a bunch of rocks in space, right? Well, no, they're quite different because they could have large amounts of platinum-based materials and rare earths, which could be extremely valuable. In fact, it could set off a second gold rush, this time in outer space. You know, Thomas Jefferson, when he doubled the size of the United States with the Louisiana Purchase, he wrote that it would take maybe 1,000 years. 1,000 years for the people on the East Coast to figure out what's in this gigantic chunk of land that he bought from Napoleon. 1,000 years, he thought. Well, it was actually done in less than 100 years. And why is that? Because in 1848, gold was discovered in California, and that was the game changer, which changed the whole destiny of the U.S. of A. Well, now these Google billionaires think that by retrieving an asteroid in space, they may set off a second gold rush of platinum-based chemicals and rare earth chemicals, which are very useful for the electronics industry. First of all, let me explain. The Earth, of course, has platinum-based materials. However, a long time ago when the Earth was molten, most of the heavy elements drifted to the center of the Earth because they were heavier. And so the composition of the crust of the Earth does not have that many of these heavy elements. However, asteroids are different. They come from a planet that never quite formed, and therefore there was no time for these heavy elements to drift to the center of a molten asteroid. No, the asteroid belt never formed like that. And therefore, by analyzing these meteorites and these asteroid fragments that we've had, we see that, yes, these asteroids could be rich in platinum-based chemicals and in rare earths. And that's why Google billionaires have already created a company to investigate the possibility of one day lassoing, get this, lassoing an asteroid and bringing it back down to the planet Earth. Also making news is the New Horizons spacecraft, which flew by Pluto. Remember, we got these gorgeous photographs of Pluto when the New Horizons spacecraft went whizzing by Pluto, but that spacecraft just kept on going. It just kept on going, and this time the New Horizons spacecraft flew by the ultimate Thule object. It's an object in the Kuiper Belt. The Kuiper Belt is a belt of comets, and in fact, technically speaking, Pluto is a member of the Kuiper Belt. So, well, technically speaking, Pluto is in some sense an overgrown comet. It's a member of the Kuiper Belt of comets, but so is Ultima Thule, one of the largest objects in the Kuiper Belt. And the New Horizons spacecraft zipped by this object and photographed it and sent back these beautiful pictures of this object, the farthest object in our solar system to be visited by a spacecraft. And what does this object look like? Well, it looks like a snowman. That's right. It looks like a snowman that you build at Christmas time. It looks like two large spheres were stuck together to create the snowman in outer space. Now, where did that come from? Well, we're not sure, but we think that at the beginning of the solar system, there was not actually one object, but two objects that were revolving around each other. And as time went by, these objects spiraled inwards slower and slower until they finally gently coalesced billions of years ago. And so we're now seeing a rather oddball object, an object shaped like a snowman, which is the merger of two objects because of gravitational attraction. And that is the farthest object that we have been able to visit and photograph in our solar system. But speaking about our solar system, there's yet another mystery, because there's an object a few years ago that sailed through our solar system, which is a visitor from another solar system in outer space. This is the first time in history that astronomers actually made contact with an object from outside our solar system, and it's causing a controversy because some professors at Harvard believe that maybe, just maybe, it's a spacecraft, that maybe it's artificial, that maybe aliens from outer space, from an intelligent civilization, built this spaceship that sail through our solar system? Well, let's back up a bit. First of all, how do we know that this object came from outside our solar system? Well, we have Newton's laws of motion and Newton's laws of gravity. From that, we can track the trajectory of this object and then run the videotape backwards. And sure enough, the trajectory of this object shows that it did not come from our solar system. It came from another solar system. And to make the mystery even more dramatic, it turns out that the object has a shape. Many people think it's some kind of cigar shape or whatever, but it's not like an ordinary asteroid at all. It has an alien shape to it. And third, to make the mystery even more interesting, the trajectory of this object wobbles a bit. Now remember that this object should be in free fall. It should be an object coming from another solar system, obeying Newton's laws of gravity and free fall, and therefore its trajectory should be smooth. But no, it seems to deviate a little bit. And so some people have speculated that, well, you can't rule out the possibility that maybe it came from an intelligent civilization. Well, as you know, Carl Sagan once said that remarkable claims require remarkable proof. And so far, we have no proof. We have these innuendos and these speculations that maybe, just maybe, it's an extraterrestrial visitor. Well, first of all, let me say that years ago, it was predicted that an object like this would, in fact, be discovered. It turns out that even in our own solar system, if a comet goes too close to the sun and goes whizzing out in outer space, it has a slingshot effect. And the slingshot effect gives it a boost of energy that would take it outside the solar system. So even our own solar system probably ejects objects into outer space periodically. And it was predicted that one day an object from another solar system would come sailing through our solar system. And sure enough, this actually happened. By retracing the trajectory into the past, we can see that this object clearly came from outside the solar system. But is it a spacecraft? Is it a project of some ingenuity of an alien civilization? We don't know, but it cannot be ruled out. And why? Because astronomers are still debating what this object is. Believe it or not, there's no consensus in the astronomical community about what this object is. It has a strange shape, it seems to wobble a bit, and it came from outside the solar system. So you can use your own imagination as to what this object is. And then more news about our universe. More and more extrasolar planets are being discovered. First of all, we should state clearly that we have not yet found the twin of the Earth in outer space. The Holy Grail of planetary exploration is to find a twin of the Earth in space. That is, a planet with the same size as the Earth, with liquid oceans and an oxygen atmosphere. We've come close, but not yet nailed it to the wall. First of all, 4,000 extrasolar planets have been discovered by astronomers on the Earth and also by the Kepler satellite, one of the most productive satellites of all. The Kepler satellite clearly identified thousands of extrasolar planets, but only by analyzing a small dot in the Milky Way galaxy. That is, the Kepler satellite did not scan the entire sky. No, it zeroed in on one direction. One piece of the Milky Way galaxy was then analyzed by the Kepler satellite. Now we have a successor called TESS, T-E-S-S. And TESS, unlike Kepler, scans the entire sky, concentrating on nearby stars. And so the Kepler satellite did, in fact, find planets hundreds, maybe thousands of light years from the Earth, but TESS wants to zero in on planets much closer to the planet Earth, planets that may actually be Earth-like.
Now, you realize that this is not an easy task, because the bigger the object is, the easier it is to detect. Kepler, for example, looked at the shadows cast by a planet that goes in front of its mother star, diminishing sunlight by, let's say, 1%. And by looking for that 1% drop in starlight from a distant star, bingo, you know that you could be tracking an extrasolar planet. Well, that's how we do it, and that means that the big planets are found first. And that's why we have now 4,000 of these planets. And the question is, do any of them look like our solar system? And the answer is no. You know, when I was a kid, we learned about the solar system, and it was told to us that the solar system that we live in is probably ordinary. There's nothing really special about our solar system. It's probably very average. First of all, you have planets in circles going around the sun, duh. And then you have rocky planets toward the center. Then you have gas giants toward the outside. And then far out beyond that is the comet belt of comets. That we thought was the typical solar system in outer space. Well, boy, were we wrong. We now realize that we are the oddball. We're different from all the other solar systems in space. Many of these other solar systems have highly elliptical orbits, or Jupiter-sized planets that are very, very close to the mother star. Or not one, but many planets in the so-called Goldilocks zone where you could conceivably have liquid oceans. So in other words, we found that in outer space, if you can imagine it, and it obeys the laws of physics, if you can imagine it, it probably exists someplace out there. Now, I remember when the movie Star Wars came out, there was a lot of snickering in the scientific community. There was a scene where Luke Skywalker looks in the sky and he sees a double star. Astronomers said, "Ha! A double star? A planet going around a double star system would be unstable, and therefore Luke Skywalker could not possibly be on a stable planet." Well, boy, were we wrong. It turns out that not only can you have a double star, but a triple star system with a planet going around it in a stable orbit. In fact, the closest planet to the Earth outside the solar system is called Proxima Centauri b, and it goes around a triple star system. A triple star system. Think of two stars that rotate around each other like a dog chasing its tail, and then a third star that rotates around at a larger distance around these two central stars. That is a stable triple star configuration, and believe it or not, that's the configuration of Alpha Centauri, the closest star system to the Earth. And that concludes the first part of exploration. In the second part, we're going to bring on astronomer Ken Croswell in Berkeley, and we're going to talk about the galaxy. We're going to talk about the big picture, about the universe, the fate of the Milky Way galaxy itself. So stay tuned as we continue to talk about the universe on exploration. Stay tuned. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is the second half of exploration. In the first half of exploration, we talked about asteroids, meteors, comets. We talked about our solar system. We talked about extrasolar planets. In the second half of exploration, we'll go even beyond that and talk about the Milky Way galaxy itself. Did you know that there's a raging black hole at the center of the Milky Way galaxy? And one day soon, we hope to photograph it with the most advanced radio telescopes on the planet Earth. And so we'll also talk about the fate of the galaxy itself. With us today is our friend Ken Croswell, astronomer of Berkeley, author of a number of great books, including Magnificent Universe, Magnificent Mars, and also Alchemy of the Heavens, talking about the nature of the galaxy, the nature of the universe itself. And so once again, our special guest today is Ken Croswell of Berkeley, and we are talking about the solar system, the universe, and the galaxy. Well, with us once again is our favorite astronomer in Berkeley, Ken Croswell, author of a number of great books, including Alchemy of the Heavens. He's written a number of great books, including Magnificent Mars and The Universe at Midnight. And today, let's talk about a sum up of what's happening in our universe. So, Ken, how did you, as a youth, first get started being interested in astronomy?
Well, it all started back in first grade when one morning our teacher introduced us to the planets of the solar system. The 9 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto, of course. And we were told we were to make a map of the planets of our solar system. And I was just fascinated that there were other planets out there. In fact, I'd never even heard the word planet before. And I'd never heard of most of the names of the planets. I think I'd heard of Mars and Saturn, but that was about it. And then pretty soon afterwards, I really wanted to communicate the love that I felt for astronomy to other people. And to me, the logical way to do that was to write. And so starting in first, second grade, I started writing about astronomy. Of course, I had no audience back then other than maybe my parents, but I imagined I had an audience. And so I basically, nowadays, I guess you could say I never grew up. I'm still writing about astronomy, which I very much love to do. And as you point out, I'm the author of a number of books, including The Alchemy of the Heavens, The Magnificent Universe, and so that's how it all started back in first grade. I never grew up.
Well, Ken, let me ask you a rather strange question for an astronomer. A few years ago, there was an object that came into our solar system from another solar system. By tracking it, we then looked at the trajectory of the object, traced it where it came from, and it came from not our own solar system, but another solar system. But it was a strange object. It had a strange shape, and its trajectory was not quite what you would expect an object to travel in if it's in free fall, acting under Isaac Newton's laws of motion and gravity. So some people think, well, who knows where it came from? Maybe from another extraterrestrial civilization. Now, Carl Sagan was famous for saying that remarkable claims require remarkable proof. And here we have some Harvard professors saying that that strange object that came from another solar system, well, maybe you can't rule out the fact that it's extraterrestrial. However, you have to have some facts behind that. You just can't say that you saw a flying saucer the other day and claim that it came from outer space, from an alien civilization. You got to have something to back it up. So how do these professors back up the statement that this craft could actually be from an intelligent civilization?
Well, I think they're simply proposing this as an idea, an intriguing idea, as to what it might be, because this object has puzzled us because of its shape. It's just such a weird shape. It's like nothing we've ever seen before. Now, again, we were expecting someday to find an interstellar comet or asteroid enter our solar system. We were actually expecting to see a comet, not an asteroid. But in terms of this proposal that it might be an alien spaceship, well, we don't have any direct evidence of that other than it's really weird. And as I say, we did listen for radio signals of this object and failed to find it. So if there really are aliens on board the ship, they're being very quiet about themselves.
Now, we have Newton's laws of motion and Newton's laws of gravity. From that, we can calculate the trajectory of this object and run the videotape backwards to see where it came from. It came from another solar system, but we can actually see whether or not it's in free fall. If it was a naturally occurring object, it would be in free fall so that you would be able to predict exactly its trajectory. So what happens when we try to calculate the trajectory of this object? Is it maneuvering of its own energy, or is it like a comet losing mass as it goes along? What is its trajectory like?
Well, there was a report that it had changed its motion a little bit, but the thinking is that that is not a sign of an alien spaceship, but instead that this is a comet that is outgassing the material, and that outgassing causes an acceleration, a push on the object, and makes it change its path. There is still, though, debate as to whether the object is an asteroid or a comet. I don't think we have settled on that. Every time I see a paper that says it's one thing, I see another scientific paper that says it's another. So we don't know what this object is. We don't know where it came from either. And I think backtracking it to a specific star is going to be very difficult, simply because over time, the stars are all moving, and this object gets perturbed by the stars, and so you can't very easily trace it back to a specific star system out there.
Okay, well, and speaking about other star systems, scientists with the Kepler satellite and now with the new satellite in orbit tests have been able to verify at least 4,000 planets circling other stars in our own Milky Way galaxy. Now, of these 4,000 planets, we haven't yet found an exact twin of the Earth. However, we had found some rather unusual, bizarre planets. I remember when the movie Star Wars came out, a lot of astronomers poo-pooed that movie because there was a scene where a planet was going around a double star system. But now we find even more bizarre situations than that. A triple star system, the nearest star system to the Earth, has a planet going around it. So what are some of the unusual oddball solar systems that we have found that caught your attention?
Well, there are so many planets out there now, it's hard to keep track of them. Certainly one of my favorite planets is the planet around the very nearest star to the Sun. That is Proxima Centauri. Proxima Centauri is a small star, much smaller than the Sun. It's a red dwarf. Typical of stars of the Milky Way, 75% of all stars in the Milky Way are red dwarfs. Contrary to popular belief, the Sun is not an average star. It's actually much more luminous than the average star. So the planet around Proxima is very interesting. We could send a spacecraft to Proxima Centauri even in our lifetime, because Proxima Centauri is located just 4.25 light years from Earth. Okay, so if we could send a spacecraft at, let's say, 10% speed of light toward Proxima Centauri, we could have data from that system 40 years from now. Of course, getting up to that high speed is very difficult, but in principle, it is achievable. So that's one of my favorite planets. This is Proxima Centauri planet.
And we've also found planets going around more than just one star, more than 2 stars, 3 stars, even more than that. We've also found planets, many, many planets, Earth-sized planets, the TRAPPIST system going around a red dwarf. So some of these planets were not predicted ahead of time by astronomers, right?
Yeah, it's very surprising to me that in some of these cases we're able to see so many planets going around one star. That means these solar systems are, first of all, very compact. Because the way the Kepler spacecraft works was to detect planets when they pass in front of the star, block out some of the star's light. So in order for that to happen, the planets have to be fairly close to the star. Most of them are closer to their star than Earth is to the Sun. And so to have multiple planets, in some cases, 6 or 7 planets, it's detectable by Kepler means you've got that number of planets located very close to the star. And furthermore, their orbits are all very well aligned, because it's only the planets whose orbits are almost exactly edge on to our line of sight that we're able to detect with the Kepler spacecraft. So I was very surprised that it was even possible for Kepler to detect multiple solar systems. In other words, those planets with solar systems with multiple planets. I would not have predicted that in advance. So that has been a real surprise that you have such a well-aligned solar system and that are so compact, very close to their stars.
Now, our solar systems, once upon a time, was thought to be very ordinary. We have planets going around the sun in more or less circles. We have rocky planets toward the sun, and we have gas giants toward the outside, and then comets beyond that in the comet belt. So once upon a time, people thought that our solar system was ho-hum, very ordinary, very average. But isn't it true that our solar system is actually the oddball, that we are the exception, that it's very rare to find solar systems with planets going around the star in near-perfect circles, in very clearly defined orbits? What are your thoughts?
Well, it's looking like our solar system, contrary to what had been thought 30 years ago, is not necessarily a typical solar system. 30 years ago, the conventional wisdom was that all solar systems were going to be like ours, with small, rocky planets close to the star, giant planets far from the star, and maybe some smaller planets like Pluto, even farther from the star. And in fact, what we have discovered is just the opposite, that we've got lots of planets out there and lots of solar systems out there that don't resemble ours at all. So, for example, take the very first planet discovered around a sun-like star. The star was 51 Pegasus. It was a giant planet located closer to a star than Mercury is to the sun. This was almost completely unexpected. We expected giant planets to be far from their stars, not close to them. And we have also detected planets with extremely elliptical orbits. For example, there's a star in the constellation Ursa Major called HD 80606. It's got a planet that has an incredible elliptical orbit. It doesn't look like a planet's orbit to us in our solar system. It looks more like a comet path around the sun because it's highly elliptical. It goes far out and then comes very close to its star. So there are many solar systems out there, but many of them do not resemble our own.
Okay, now the holy grail of planetary astronomy is to find a twin of the Earth in outer space, and one indicator of a twin of the Earth would be liquid water oceans, because we think that's where life started on the planet Earth. So of the different planets that we have analyzed so far, do any of them look like they may have oceans on them?
We have no information on that right now. So that is something that we are hoping to pursue in the future as we try to find smaller planets like Earth. See, the thing is, it's much easier to find big planets than little planets, right? So the very first planet discovered around a sun-like star was a planet about half the size of Jupiter, half the mass of Jupiter. Such planets are fairly easy to see. Planets as small as the Earth are not nearly as easy to see. Jupiter is 318 times more massive than the Earth, okay? So in some sense, the Earth is 300 times harder to find than a planet like Jupiter. So that's the situation we're in. And right now, we don't have any planet that we think has an ocean the way Earth does.
What about chemicals? Chemicals like oxygen that may indicate the presence of Earth-like life on these kinds of planets. Do we have any understanding of the chemical composition of the atmospheres of these planets?
We have begun to study the atmospheres of some of these planets, especially those planets that pass in front of their stars, where we can see the starlight passing through the planet's atmosphere. But we don't have anything that suggests the sign of life. For example, as you mentioned, in the case of the Earth, we've got oxygen in our atmosphere. That's actually a very unusual thing because oxygen is a very reactive element, and it should react very quickly with the surface and disappear. And, of course, the only reason that Earth has oxygen in its atmosphere is because plants and trees are pumping the oxygen into the atmosphere. So even if we didn't know Earth had life, we might be able to deduce it has life simply from the presence of oxygen in the atmosphere.
Now, the Kepler satellite, which was the workhorse of analyzing extrasolar planets, well, it's crippled, so we can't really use it now. But the Kepler satellite focused on one spot in the Milky Way galaxy. Now we have TESS, the successor to Kepler, and it's scanning the entire heavens, not just one fixed spot in the Milky Way galaxy. So do we expect, therefore, to have an even bigger treasure trove of extrasolar planets coming from TESS?
Well, I'm not sure it's going to be a bigger treasure trove, but the planets that this new satellite is detecting are planets that are much closer to us than the Kepler discoveries. The Kepler discoveries were often hundreds or thousands of light years away. The TESS discoveries are going to be around brighter stars. Many of the stars are going to be red dwarfs. Again, red dwarfs are the most common type of star in the galaxy. They outnumber all others put together. They're smaller, cooler, fainter than the sun. Proxima Centauri is a good example, but there's many, many others out there. And so many of these stars, many of these planets, the TESS, the satellite is discovering, are going to be going around red dwarfs nearby. And since they're nearby, that gives us a good chance to follow up the discoveries with large telescopes here on Earth or with Hubble. So the hope is to, rather than to discover a huge number of new planets, but simply to try to find planets that we can better characterize and actually answer those questions that you were asking, such as, do they have atmospheres, do they have oceans, and of course, do they have life?
Okay, now moving beyond just the extrasolar planets in our vicinity, let's talk about the black hole at the center of the Milky Way galaxy. It turns out that we are able to lash together many radio telescopes on the planet Earth. In fact, I visited some of these radio telescopes, and by lashing them together, we get an effective radio telescope the size of the planet Earth. And they tell me when I visit these radio telescopes that one day we're going to focus in on the black hole at the center of the Milky Way galaxy. We're getting very close now. So can you tell us a little bit about what lurks at the center of the Milky Way galaxy?
Yes, the very center of the Milky Way galaxy is a giant black hole, the biggest black hole in the Milky Way galaxy. It is 4 million times as massive as the Sun. And everything in the Milky Way galaxy that's down to the Milky Way goes around that black hole. So in some sense, that black hole is the sun of the Milky Way galaxy, just as all the planets in our solar system go around our sun goes around that black hole. Every 230 million years, that's how long one orbit takes. That's how big the Milky Way galaxy is. And as I mentioned, this black hole is by far the biggest in the Milky Way galaxy. But many other large galaxies throughout the universe also have supermassive black holes at their centers. And in fact, some of these black holes are much bigger than ours. Some of them are not millions of solar masses, but billions of solar masses. One of the strange things about our black hole is that it's unusually quiet. It really doesn't do much. And yet we think that in times past, it probably was much more active because gas was falling into it, or stars, or maybe even star clusters. So presumably in the past, and also at some point in the future, this black hole, whose name is Sagittarius A star, will flare up. But that may not happen in our lifetime.
And also, by lashing together all these radio telescopes, people hope to actually photograph what is called the event horizon. However, given the fact that black holes are black, I'm not sure exactly what they're going to pick up. But tell us a little bit about what they expect to find as they get closer and closer to the black hole at the center of our galaxy.
Yes, this black hole, Sagittarius A star, is the closest supermassive black hole to the Earth, and therefore, in some sense, the easiest one to study. It's 27,000 light years from the Earth, which is far enough so we don't have to worry about it, but close enough that we can study it in some detail. And the hope is, as you say, to at the event horizon, the point of no return around this black hole, just by linking together radio telescopes. Because radio astronomers have the advantage that they can link their telescopes together and create incredibly sharp images of the sky. So the hope is that we'll be able to see the event horizon around Sagittarius A star. That's the hope for the future, and it will be very interesting to see what happens.
Okay, and I understand that you've recently written an article. You got your PhD specializing in galactic physics. So tell us a little about your recent work.
Yes, in the April 2019 issue of Sky and Telescope, there is an article all about spiral galaxies that I wrote. And this article explains how spiral galaxies, even though we kind of take them for granted because they're so common, that 70% of the bright galaxies in the universe are spiral galaxies, including the Milky Way. Milky Way is a spiral. But these galaxies are actually under threat because in order to maintain their beautiful shape, they have to acquire more gas to replace the gas that is lost as they create new stars. So let me back up a moment and just tell you what a spiral galaxy is. The spirals are the most beautiful of all the galaxies. They look like a glowing cosmic hurricane, a pinwheel in space. And indeed, all of them are spinning very fast. So, for example, we, in the next hour, will move 500,000 miles to space as the sun orbits around the black hole at the Milky Way center. So all of these spiral galaxies are spinning fast. In fact, you can tell that by looking at the very beautiful photographs in the April 2019 issue of Sky and Telescope. You can just sense that they must be spinning from the shapes that they have. And all of these spiral galaxies have gas. And the gas is the raw material for making new stars. In fact, 5 out of the 6 stars born every year in the universe are born in spiral galaxies, like the Milky Way, like the Whirlpool Galaxy, like the Andromeda Galaxy. But the problem is, as they create new stars, they are running out of gas. And gas turns out to be essential to spiral structure because gas clouds are very large, and so they can smash into each other if there's ever any turbulence in a spiral galaxy. Turbulence is the enemy of spiral galaxies. In order for a spiral shape to emerge, the galaxy has to be fairly tranquil because you want the disk of the galaxy to stay thin so that everything is close together and gravity can operate to mold these beautiful galaxies into spirals. And so the question is, will spiral galaxies be able to acquire enough gas in the future, the far future, over the next few billion years? Because when you look at the numbers for the Milky Way, the numbers are, as I point out in the Sky and Telescope article, rather bleak. We have about 1 to 2 billion solar masses of molecular gas in the entire Milky Way. And it's molecular gas that gives birth to stars. This is a gas of coldness and density, so it's most likely to form stars. And yet we're forming about 2 solar masses of stars per year. So if you divide the one number by the other, you discover we have a molecular gas supply of only about 1 billion years left. So in other words, if we don't acquire more gas, we're going to run out of gas in just the next billion years. And the Milky Way is not unique in this regard. Other spiral galaxies have the exact same problem. They are consuming their fuel at a very high rate compared to their gas supply. And so the question posed in that article is, can they acquire more gas in the future? And different astronomers have very different opinions. One astronomer I interviewed said that spiral galaxies may not survive for much past another 2 or 3 or 4 billion years, whereas others think maybe they can survive for another 15 billion years. But sooner or later, the beautiful spiral galaxies that adorn the universe will probably disappear. So we live in a very nice time right now that in the article I call the spiraliferous period, the period when there are lots of spiral galaxies out there. But if we come back in 20 billion years, we may find that most of the spirals have turned into other types of galaxies that are not nearly as attractive as spirals.
Now, Ken, on a scale of billions of years, not only do we have to worry about our spiral galaxy running out of gas, but we also have a potential collision with Andromeda, a neighboring spiral galaxy that could take place on a scale of several billion years. And maybe coming out of that would become a giant elliptical galaxy. So do you think, therefore, that our galaxy will continue to shine bright especially if we have a collision with a neighboring spiral galaxy, Andromeda.
Yes, that collision will probably occur about 5 billion years from now. And in the initial stages, it will probably stimulate star formation activity in both galaxies, both Andromeda and the Milky Way. So we're going to, in some sense, be more glorious than ever when that collision occurs. But then, as you say, the two spiral galaxies will merge into one and lose their spiral shape and likely become a giant elliptical galaxy, similar to the galaxy M87 in the Virgo cluster. And let's be honest, elliptical galaxies aren't nearly as attractive as spirals. So it looks like, unfortunately, our galaxy and the Andromeda galaxy are fated to lose their spiral shape due to that collision. The question, though, is will the Milky Way run out of gas before that collision occurs? Because if it were to run out of gas, let's say, in just 1 billion years, then it will lose its spiral shape probably a billion or so years after that, simply because it doesn't have enough gas to maintain its spiral shape. Fortunately, in the case of the Milky Way, there are two large satellites that are full of gas, and that is, these are the large and small Magellanic Clouds. These are galaxies that go around the Milky Way. There's lots of galaxies that go around the Milky Way. That's how big the Milky Way is. They're losing lots of gas. And on page 18 of the April 2019 issue of Design Telescope, you can see a beautiful image that shows this gas stream that the Magellanic Clouds are losing to the Milky Way's outer halo. So that gas is a very massive, many billions of solar masses. And if it falls into the Milky Way's disk, it could sustain the Milky Way's spiral shape for many billions of years to come.
Well, let's hope that enough gas falls into the Milky Way galaxy to sustain its beautiful spiral structure. Well, Ken, unfortunately, we have run out of time. Once again, our special guest today was astronomer Ken Croswell of Berkeley, and the book is called Alchemy of the Heavens, and we've been talking about the universe with Ken Croswell. And once again, this is Dr. Michio Kaku for Exploration.